Domain and range of functions. So we have talked about these sort of when we did each one. Okay, so if you recall, let me just give you a little graph. If I just graph the parent function for a quadratic. So it goes through 0, 0, kind of looks like that. Okay, do you remember which one's which? Domain is what values and what's range?
All real.
The domain is all real here because it's all your x values. So the domain are your x values. I'm going to say x values represented in graph. And then your range are the y values. So if I look at my graph for a quadratic, remember, these arrows indicate that it's going to keep going forever in both of these directions. So the reason why the domain for a quadratic is all reals, I can plug in any value I want for x, right? When I plug in 1, there's a number. When I plug in 2, there's a number. When I plug in 17, there's a number. It's just going to be way up there. When I plug in -1, there's a number. When I plug in -2, there's a number. No matter what number I plug in for x, there will be a number that corresponds to it in the y's. Right? If you look at just the equation, y equals x squared, there's no limitation on what I can plug in for x. I can plug in anything I want. So our domain for all quadratics, all reals. Now the range, if I'm looking at y equals x squared, the range represents, well, what are the y values that are going to come out? I have y values starting at 0 all the way up, and they're going to keep going forever. I'm eventually going to get every single y value up here. Am I ever going to get a y value down here? No matter what you plug in for x, you will never get out a negative y value. It's impossible because I'm going to take a number and I'm going to square it. So whether that number that I put in was positive, it would come out positive. If I put it in a negative, it would come out positive still. If I put in 0, it comes out as 0. So there's no way for me to get a negative number. Okay, and I think it's easier to see that from the graph. So I can look at the graph and say, oh yeah, this graph will cover every x value ever, but the only y values are the ones from 0 and up. So my range, y has to be greater than or equal to 0. Does that make sense? Is everybody okay so far? Now, let's change things around a little bit. What if I had, let's see if I can fit it on the same one. What if I had this graph? Quadratic again, but maybe I put it over here. That's 1. All right.
Wait,
Yeah.
so domain doesn't mean anything? Like it's just x equals, like, it doesn't matter? Like, you don't, like, it doesn't make a difference with the graph. It's just x equals real all the time.
For a quadratic, yes. But for something like a square root, no. It's going to make it. It's basically what x values can you plug into the equation. I can plug in anything into this, and I'll get an answer back out for that. But in a square root, you can't take the square root of a negative, right? So I'm not allowed to plug in negatives if I had a square root. Okay, so let's look at this one. The domain. Are all of my x values going to be covered forever? Can I plug? Well, actually, let's write the function of this first. What have I done to this quadratic? I flipped it upside down, so how will I write that? Negative out in front. Looks like I've also moved it to the right. That's 2 spaces. I moved it to the right 2 spaces and up 1. So what does that look like in my equation? If I go right 2 and up 1, it'd be x and then what? Minus 2, close it, square it, and then plus 1 on the outside. Okay, so there's my equation for this. Now let's talk domain and range. If I have the graph of it, I don't know, me personally, I think it's easiest to look at the graph to figure out domain and range. Won't these arrows keep going out forever and ever, and every single x value will eventually get covered? Do you agree? Yeah, so that's how I know x is all reals. It is true that it will always be all reals for quadratics. It's not always all reals for everybody. And how about the range, though? Looks like I'm getting all these values, but I'm never going to get ones up here. So the range needs to represent all the ones that I'm going to get. So what are they? Y is less than or equal to 1. Right? I can get a y value of 1 and anything lower than it, but I'll never get a y value that's 2 or 7 or 21. So there's my domain and range of that one.
Is range like the vertex?
Kind of. It's the, yeah, and it all deals with the y values. Y values. Okay, let me give you one quadratic one to try, and then we'll try a different function. So let's say we did this one. So there's a quadratic that I just shifted to the left 1. So go ahead and try and write its equation and then figure out its domain and range. Okay, what does this equation look like? Y equals what? X plus 1 in parentheses. Anything else? No, because I didn't move it up or down, so I'm done. I just shifted it left 1, so I just put the plus 1 in the parentheses with it. Okay, domain will be all reals. It is always all reals for quadratics. These sides of my graph are going to go on forever and cover every x value forever. And the range would be y is greater than or equal to what? 0, correct. I have a y value of 0, and I will get every y greater than it. Does that kind of make sense? Okay. So let's try some square root ones now, because they are different. Let's see if I can get everything on the screen at the same time. Okay, let's just look at the parent function for a square root. So those ones, I should be using different colors. I have all these beautiful colors. Why not use them? Okay, so there's basically my square root parent function. So let's just write that, square root of x. Oh dear. Okay, so for the domain, it is not all reals anymore. This graph starts here and it goes this way forever. This graph is not going to cover any x values over here, right? It's not it doesn't have an arrow on both sides, so it's not going on forever and ever and ever and ever. So, who thinks they could tell me the domain for this one? X is what? Jess? Greater than or equal to 0? Is that what you said? Perfect. Oh, sorry. This domain starts at 0 and then goes to all the positives. And what would the range be?
Y is all right? I mean, no, wait. Y is greater than, I mean, yeah, 0.
Yes. So in this one also, the y values start at 0. This is going to keep going up forever. It just gets slower and slower. But I eventually will get every single y value in the positive direction. Okay? Let's try moving this square root around a little bit. So let's try another square root graph. Maybe one that looks like... let's put it here. So I have taken this square root function, I moved it to the right one and down 2. So go ahead and try and write its equation. And then see if you can determine its domain and range if you haven't already. Okay, what is the equation of this one? Y equals what?
X minus 1 minus 2.
Perfect. To the right one, down 2. Let me zoom in on this part. Right? So whatever I'm doing, left or right, goes in there with the x. I know right 1, normally you think plus 1, but you got to put the opposite in there with the x. And then down 2 is a minus 2. All right, domain. This time, my graph starts here, and in the x direction, I'll get all of these x's. But I'm never going to get any x's over here. So what does my domain, what's it?
Greater than -1, or x is greater than 1.
Greater than or equal to 1. Yes. Perfect. The only x's that I have represented in my graph starts at 1 and everything bigger than it. Okay? And then the range would be y is? You got it. Greater than or equal to -2. Right? That's the lowest y value I have, and then I get everything above that. Okay, one more. I'll let you try it. Let's see how this goes. I wonder if you can come up with this equation. Oh, you can't even see it. All right. Let's do this one. Try and write the equation for that. And then determine domain and range. Ooh, that's a good one. Okay. Does anybody think they have the right equation? Go ahead, Ashley.
Y equals the square root of x plus 2 plus 1.
You are almost right. I like the plus 2, indicating that I go left 2, and I am also shifting up 1. But,
Negative in front of
yeah, this whole thing got flipped upside down, right? Because if you look at the last one, look at the parent function. It's like arcing upwards, and this guy's arcing downward, so he must have gotten flipped over at some point. So make sure you have the negative out in front. And the domain here would be x is what? Go ahead, Ashley.
greater than or equal to 2
Ooh, you're so close.
or negative 2.
Negative 2, yeah. My x values start at negative 2, and then I'll get everything greater than that. Right? So just look at where your graph starts. I'm starting in the x values at negative 2, and then I'll go this way. And the range, y is going to be careful on this one. Y will be, Alexandra? Look at your y values, right? The highest y value I have is 1. What other y values will I get out? Won't I get ones that are less than 1? I got 1. I'll also get all these ones down here. Does that make sense? So for my range, I'm going to have y is less than or equal to positive 1. Does that make sense? Yeah? Everybody's all right? Okay. So, let's stop this here then. Well, I guess if you had a different style graph, absolute value, they all work the same way. It's just, well, let's do one of each. Why not? Let's say you were working with say you had that absolute value graph. Y equals absolute value of x, and then, oh wait, what else do I need besides the plus 1?
Negative.
I need a negative out in front because it's all flipped upside down, right? So I need a negative right there. So there's my equation. Domain would be what? That's range. Look at your x values. What'd you say? All real. Look at this is going to go forever this way. This is going to go forever this way. They're going to cover every single x value ever. Right? You can plug in anything you want into the x slot. All of them will be covered. So domain will be all reals. So just like with quadratics, domain was all reals, right? Because these arrows just keep going. They're going to cover all of the x's. It works the same way for absolute value because, again, both of those sides go on forever. But the range does not. What would the range be here? Y is less than or equal to, it should be 1. Sorry. I know it's, you guys can't really see the dots on here. I meant that for it to be 1, that's 2, and so on. Right? The biggest y value I have is 1, and then I have everything below it, but I'll never get a y value outside of that. Okay, and then let's also just do, maybe we'll do the cube root one. Oh, let's say I took my cube root and I did, let's Let's move it a little bit. So this is not the parent function. The parent function would have that at the origin. So I moved it a little bit. Looks like I went to the right one, up one. So a cube root function that's moved right one, up one would look like cube root to the right one, up one. So there's its equation. Now I ask you to ponder, what would the domain and range be? Go ahead and write down what you think the domain and range of this green graph is. Let me try and make it a little darker. Okay, what do we think the domain is? Anybody have a guess? Yeah, it's all reals. These ends of the graph go on forever, so they are going to cover every single x value ever. What about the range? Any guesses? I'm going to get every y value also. This is going up slowly, but it's going to go up forever and ever and ever and ever in that direction. This is going to go down and down and down and down forever in that direction, just slowly, but it'll eventually get there. So that every y value will get covered eventually. Because this one just goes up forever, this one goes down forever, so I've covered everybody. Does that make sense? Okay. Do we feel like we have somewhat of a handle on domain and range? Okay.